Okay, let's look at vector addition. If I had one vector, and it's the vector A, and that vector A, if I knew, had, in reference to a north point, was on a bearing of 40 degrees, and it also had a magnitude of 5 units, then I had another vector which, in relation to a north point, was on a bearing of 100 degrees. I'm going to call this vector B, and it had a magnitude of 3 units. What would be the magnitude of the resultant vector, and in what direction would this resultant vector be heading towards? So using vector addition, I can add these two vectors together as long as I add them head to tail. So if I have the vector A here, and I add to that the vector B, so this being A of 5 units, this being B of 3 units, and then if I think to myself, what do I have in relation to the angles? Well, I said this one was 40, and this one here is 100. Well, if that one is 40, then via corresponding and co-interior angles, first off co-interior, this one here would be 140 degrees, because they must add up to equal 180. So if that's 140, if that's 100, that's 240. I'm left with 120 degrees is my angle that's inside there. Now this is important because now if I've got this vector A, this vector B, I want to find the resultant vector C, and I want to find what its magnitude is. Both of these 5 and 3 units are the magnitude. So if I think to myself, I'm looking for the magnitude of vector C is equal to 5 squared plus 3 squared. Take 2 times 5 times 3, the cos of 120. Of course, here I'm using the good old cos rule. Working this out, I'd therefore get that this would be 25 plus 9, take 2 times 5 times 3 times the cos of 120. And calculating this out now, I'd get the answer that that would be 49. So the magnitude of C squared is 49, therefore the magnitude of C by itself is 7. I also need to determine now what this angle in here would be. Let's call it theta. So by looking at theta there, I can now use the sine rule, and I can say that the sine of theta is over 3, so that's its opposite side there, is equal to the sine of 120, and its opposite side is now 7, what we calculated it out. So rearranging, the sine of theta is equal to 3 sine 120 over 7, and I can work out that theta then is equal to 21.8 degrees. So approximately 22 degrees. Now if that is 22 degrees, theta, then the bearing of this vector C from my north point would be the 40 to this vector A plus the 22, that is theta now. So this would be on a bearing of 062.